Hello everyone, this is Akshay Madiwalar. Today my presentation topic is adaptive distributed caching based on optimal placement strategy and eventual consistency. Uh, to start off with the introduction, distributed caching basically is a powerful tool for improving the performance of data intensive applications. By caching frequently access data on multiple nodes, distributed caching reduces the time it takes to retrieve and process the data, leading to faster response times and increased scalability. However, current cache systems have some potential drawbacks, such as the need for centralized coordination, single point of failure, and increased network latencies. To address these issues, we propose a strategy for adaptive distributed caching based on optimal placement algorithms and eventual consistencies. We also propose optimal placement algorithms for cache nodes and data object replacement algorithms based on greedy approach over traditional replacement algorithms. So in this presentation, we'll discuss the importance of distributed caching, the potential drawbacks of the current systems, and the need for adaptive caching systems. So when we talk about the objective, so the objective of this research paper is to propose a strategy for adaptive distributed caching that improves the performance and scalability of data-intensive applications. So our solution aims to address the potential drawbacks of current systems, such as the current systems are based a lot on centralized coordinated server, which can lead up to single point of failure or increased network latencies. So to achieve our objective, we propose a strategy where we use a lot of optimal placement algorithms for cache nodes that reduce network latencies and increase the performance. Optimal replacement algorithms for data objects based on greedy approach over traditional replacement algorithms. Those can be FIFO, LRU, and LFU. The use of virtual nodes to ensure high availability and eventual consistency. So our proposed solution is based on eventual consistency, which ensures high availability according to the CAP theorem. When we talk about the current methodologies that are existing in the present scenario, the data intensive applications often require fast and efficient access to large amounts of data. But the traditional caching systems are limited by the amount of memory available in a single machine. Also, traditional on the current distributed caching systems have some potential drawbacks, like they're a lot dependent on centralized coordination, ensure load balancing and synchronization, which can lead up to a single point of failure and increase network latencies. Additionally, as the number of cache nodes increases, it becomes so complex and reduces the optimal performance. To address these issues, we propose a strategy for adaptive distributed caching that eliminates the need for centralized coordination, optimizes the placement of these multiple cache nodes, and uses optimal placement and replacement algorithms for data objects. So, in that case, our proposed solution is an adaptive distributed caching system that eliminates the need for central server and optimizes the placement of cache nodes to improve performance and scalability. Some of the key components of our solution include the caching system that maintains agreeable number of duplicate objects and locations across multiple cache nodes to eliminate the need of centralized coordination server that hence is the adaptive distributed caching and the optimal placement algorithms. Our system uses optimal placement algorithms for cache nodes that reduce network latencies and improve performance. The replacement algorithms, those can be based on the greedy approach like a FIFO, LRU, least frequently used and the least recently used. Optimize the replacement of data objects in the cache. This approach ensures that the frequently accessed data objects are prioritized for caching. And also the use of virtual nodes. We use virtual nodes to ensure high availability and eventual consistencies. Virtual nodes can be added to the cluster to increase the number of replicas, the number of basically the replicas of cache nodes for each data object, reducing the likelihood of data loss or inconsistency. When we talk about the anticipated performance, with this approach, we anticipate that the read performance and write performance are increase when compared to the traditional caching systems. So with respect to read performance, we anticipate that there can be an improvement of 50% over the traditional cache systems and 30% improvement in the write systems, the write performance. And the scalability, our system also scales well with number of cache nodes. So it's anticipated that as and when if there's a lot of traffic coming to the server, the cache nodes can scale automatically and with minimal degradation in performance as the number of nodes increases. Fault tolerance: the system is anticipated to demonstrate a high fault tolerance with minimal impact on performance whenever the cache node fails. With respect to network latency, the optimal placement algorithm significantly uh, can reduce the network latencies, improving the performance of data intensive applications. Overall, the system improves the performance of data intensive applications while ensuring the fault tolerance and eventual consistency according to the CAP theorem. In conclusion, in this paper, we proposed an adaptive distributed caching system that significantly improves the performance and scalability of a data intensive application. The system ensures optimal placement of these cache nodes, reduces network latencies, ensures eventual consistencies of data through the use of virtual nodes and asynchronous updates for the write backs. The results also demonstrate that the anticipated results can significantly uh, outperform the traditional caching systems with up to 50% improvement in the read and then 30% improvement in the write performance. Also, it's anticipated that the system can be fault tolerant with minimal impact on performance whenever the cache node fails. So that's it, and thank you.